Hello, welcome to this presentation on what is cloud computing and an introduction to a model I call shared ownership utility computing. An overview of what we're going to discuss, some introductions to who I am, in case you don't know. I'm going to show you a brief introduction to how the cloud works. I'm going to introduce you to the shared ownership utility computing model, which I might have invented. I'm not sure. It's probably out on the internet somewhere. It's something that you've learned from working with the cloud. And then at the end, I'll be around for any questions you might have. Who am I? If you don't know, I'm Joe Burchett. Here are some email addresses that you can contact me if you're interested in doing so. Some of you may be curious, but are too polite to ask what a 40-year-old dude is doing in CS-101. Reason is that I left LCSE for work in Seattle about 15 years ago, and I never took a degree, but I'm trying to fix that. I'm in a good situation to do that right now, and instructors at LCSE have been really useful or really helpful in that regard. I've spent about a year working at Amazon Web Services, and I spent about 8 years working at a smaller cloud provider in Seattle. Why am I? I don't know. Nobody knows. If you're looking for me on the internet, if you see this duck, that's probably me. Kind of my call sign, I guess. All right, so when people ask about the cloud, one of the glib answers about what it is, oh, that's just somebody else's computer. And while that's true, it doesn't really tell us anything about what this system is and how it works, or it doesn't really give us any useful information. So there's a model I prefer that I call shared ownership utility computing, and we'll get to that. But first, we need to kind of define what a cloud service is and what its characteristics are. Characteristics of cloud services. Users each have a slice of a larger collection of resources. So you have a big set of resources that exist somewhere, and then whoever is purchasing that gets a smaller slice of it. Hardware that runs these computers is virtualized in some way, meaning that the actual hardware that's running is presented to operating systems through an intermediary that we call a hypervisor. And then these cloud services have APIs, access control systems, then some sort of metering or billing to know what you've been using and how much you should be charged for it. What resources are we talking about slicing up? Generally, we have three things that comprise a computer. We have the compute resources, which are generally the CPU and memory. And the way a computer is going to work is it has some way of retrieving a piece of data. You can look at that data and then decide what action to take from that, either to grab another piece of information from some location or to perform some operation. So taken together, we have a CPU and we have memory, and those form a computer. So compute is one of the three resources in a cloud environment. Next, we have storage. So this is anything that's going to take data and persist it over time. So if a computer is rebooted, or if you want to take something and move it away from things that are being actively computed, you're going to move it to your storage device. And then third, not every computer has networking, but any computer that's going to be part of the cloud will need to, because that's the way you're going to access it. So a computer can just be compute resources, CPU and memory. But to be useful in a cloud context, we have compute resources, storage resources, and networking resources. So we have big bulk resources in these three categories, and we're trying to figure out how to slice them up and resell them to a consumer. Given those three resources, we take those slices and we present them using a specialized operating system called a hypervisor. A hypervisor's job is to produce what we call LPARs, or logical partitions. A logical partition is going to take some portion of each of these three big bulk resources and present it as though it's a single computer. On top of that LPAR, we can now present that as a single machine, and we can install an operating system on that. We can put Windows here, Mac OS, Linux, whatever it is that we want. As far as the operating system is concerned, for most intents, this is a real piece of hardware, and it's just running on it. And once we've installed an operating system, we have some way of controlling that LPAR. We call that a virtual machine. A virtual machine is, for all intents and purposes, a computer that exists somewhere on the internet. It's connected to the internet. And as far as services using that computer know, it might be running as a real device, it might be running as a virtualized device. We don't know. Okay, so once we have hypervisors and we have these virtual machines, we need a way to control those as a consumer. We need a way to present those to the internet or to use them in some way. So we have our hypervisor, we have our VMs, we have this happy little guy here that's interacting with our little basic cloud. And there are two ways that they're going to do it. There's going to be some sort of client or API that they interact with. Excuse me, there's going to be some client that interacts with an API. Usually this is using some protocol like REST or SOAP or something like that. This API allows our user to perform some actions. This is a really small set of actions that they may perform. The API will present a lot more in a real case, but they might do something like create a resource like a VM, delete a resource like a VM, or extract some info about, hey, how many VMs do I have running? How much is that going to cost me for my monthly bill? Something like that. When we launch these VMs, our hypervisor is going to report back to a metering system. It's going to tell us how many CPU cycles are being used, how much memory is being used, how much storage is being used, bandwidth that's being used, things like that. And all of this metering information is going to be used to bill the consumer at the end of the month or whatever the billing cycle is. Okay, so we have a basic little cloud. We have some virtual machines. We have a way to charge consumers. We have an API that allows us to interact with that. What do we do with it? So with this magical bit of virtualization and this presentation layer through the API, this allows a cloud operator or a service provider to sell these smaller portions of their bigger compute systems. The scale of the provider is big. And because it's big, it allows us to take advantage of economies of scale. So we can smooth over spikes and peaks in usage patterns. We can do things like aggregate large sets of services, spread them around so that we can improve the overall efficiency of the system. And the improved efficiency is where the cloud provider makes their profit. So the consumer's advantage is that you have less overall complexity that you need to manage. You don't need to manage hardware in a data center. You don't need to manage ISPs, things like that. And you're only going to pay for the resources that you're actually using. You do, however, have to pay a higher premium per unit of each of these resources. So there's a markup, just like any sort of retail service. So when you're trying to use, if you're working like DevOps or something like that, somebody's trying to sell these things to you. You're going to hear these terms OpEx and CapEx. OpEx means operational expenses. CapEx means capital expenses. And this basically refers to how these things are taxed. There are some tax advantages to using operational expenses. Capital expenses need to be depreciated over time. It's all very boring, but firms tend to prefer OpEx because there are certain tax advantages there. And cloud resources can typically be sold as an operational expense rather than a capital expense. So that's a thing that'll come up if somebody's trying to sell these things to you. All right, so we've talked about utility computing. What about the other side of this, shared ownership? So anytime we have software that's running in a networked environment, like two pieces of software that are communicating with each other over the network, any sort of distributed system like this, we're going to have concerns like this layer cake that I'm showing you. Shared ownership makes a provider of some sort responsible for lower levels in this layer cake so that a consumer operating at the higher levels could ignore those lower levels and separates the ownership of this overall system. In the real world, what we typically call the cloud begins at this virtualization layer and works down, and the consumer gets to ignore all of those things. And the services that operate in this higher layer of this cake are typically sold to us using these buzzwords SaaS, PaaS, and IaaS, which stand for software as a service, platform as a service, and infrastructure as a service. This is a more complete representation of these tiers. So if we look back at this layer cake, we have this cloud piece in the green layers, this on-prem piece in the blue layers. We can look at PaaS, SaaS, and IaaS as cloud services, and then we can look to the left of that for on-prem services, things that are actually going to operate in a data center or where the consumer is responsible for operating the computers themselves. So I add in this model 3 additional columns. Anything that's hosted, the consumer is responsible for these blue pieces, including the virtualization, so they're operating hypervisors. Anything where you're dealing with DC co-location, you actually need to care about the physical servers and the networking between them. So you own the hardware, but somebody else owns the facility into which it's installed. And then in a full DC case, you own everything from the top down. So you actually have to be responsible for fire control systems, physical security, power to the data center, and things like that. In the real world, uh, most large-scale systems are some hybrid between cloud services and on-prem services. So a more complete model like this, I think, is a lot more useful for understanding how shared ownership utility computing works. All right, so to summarize that, it's a lot of information. Generally, what we call the cloud, yes, we can say that this is somebody else's computer. That's true. But I think that it's more useful to think of this as shared ownership utility computing, meaning that we can operate the cloud as a utility with large-scale resources that are sold in smaller units. And it's important to think of this in a shared ownership model, meaning that you are going to own some portion of this service. Somebody else, the provider, is going to own lower level portions of that service. You need to interact between the two entities to make sure that everything operates as expected. It's important to understand that cloud services may reduce the total cost of ownership for any sort of service that you're building, and it may reduce the complexity that the consumer is required to build, but it doesn't necessarily. And to be able to take advantage of that, you kind of have to understand like where your costs are, where the complexity is, things like that. It's not a panacea; it doesn't fix everything for you out of the gate. So it's also important to remember that you only pay for what you use, but you do pay more per unit, and you are required to give up some control. So you're probably not going to be able to, swap RAM or hard drives in and out of these computers. And some cases, that's not going to work out the way you hope. All right, so that's all I have. Does anybody have any questions?